All right, so for the zero in attendance here, just wanted to kind of go over today a little bit more with the foot and ankle. So a few of you have turned in the knee assignment, and it looks like you guys are doing pretty good with that. So quite pleased with that. We'll be covering the foot and ankle here for at least this next week here. So we might actually get this wrapped up by, let's say, hopefully by around the 6th. And that'll give us some extra time to kind of get into the last stuff. Most likely what I'm going to be doing is eliminating this part of Unit 8, which is the functional activity, sports analysis, and movement screening. I might cover it, or we might be able to cover it like the last week of class, but I'm not so concerned with you guys knowing all of that. What I really want to make sure we do is get the gait analysis in, and as well as the spine here as well. Obviously, the exam is not going to be in class, so I will have this edited so that you'll be taking it online. But it'll be pretty much the same format as you had last time. I might have some more questions, but they're all going to be multiple choice. What I'm planning on doing is giving you at least multiple attempts for it, so it won't be a kind of a one and done thing for you there. All right, so really the 3 things I wanted to accomplish today was to go back over the anatomy for the foot and ankle, and then also do a couple of tests that I wanted to kind of go over with you here in terms of what you'll need to know that's kind of important about the foot itself. All right, so like we were talking about before, there's a lot of bones in the foot, and you have 3 segments to the foot. So your foot is divided into a hind foot, midfoot, and forefoot. I'm not so concerned that you remember that, but just know that you do have different segments to the foot. It's the exact same kind of thing as you would have with the wrist and hand. So for example, your, say, hind foot would be the same thing as your wrist itself. So that would be kind of like your actual wrist bones. Your midfoot primarily is going to be kind of what like the bottom of your palm would be. And then the forefoot would be really what the majority of your palm is, plus all your fingers. So that just to kind of give you a comparison to what that is. Remember that the bones in the midfoot and the rear foot are all named. Everything in the forefoot is numbered. So just like the metacarpals and the phalanges or your fingers are numbered, so are the metatarsals and the phalanges that make up your foot. Your big toe is number 1. So big toe is number 1, pinky toe is number 5, and that goes for everything from the toe itself and also the metatarsal itself. As far as named bones, you'll need to remember, and we'll be covering this again when we get into the special tests here as well. You should remember the navicular bone, the talus, and the calcaneus. The calcaneus is your heel bone. That's important because that's where your Achilles tendon attaches. Your navicular bone we'll be talking about later when we talk about arch height and navicular drop. And your talus is important because this forms your actual ankle joint. So you have a talar joint here, or your talar crural joint is what it's actually called. And that talar crural joint is what your actual ankle is. So this right here is the talar crural joint. So that's where the tibia, so this is tibia here, fibula there, and this here, which is the talus, that forms that talar crural joint. So this is the ankle itself. That's why these 3 are important, because that's your actual ankle. When you move your ankle, this is the joint you're moving. So the talar crural joint is what actually gives us our dorsi and plantar flexion. And this combined with your subtalar joint gives you inversion and eversion. So primarily the only bone that's moving in your foot is your talus. That's kind of the only bone that actually moves, and it really doesn't move. It's just kind of acting as almost like a hinge, almost like a modified kind of hinge. It's actually more of a saddle joint than anything. So this is kind of like what your thumb does in your wrist hand is what your ankle does. So these are your two most important joints because that collectively is what makes up your ankle movements themselves. And then all your other joints are just going to be combinations of the two bones that make up that joint. So calcaneal cuboid, that is your calcaneus, which is right here. So your calcaneus bone or your heel bone, and your cuboid bone, which attaches right next to it. Kind of looks like a cube, hence the name. But these two attach, so that's why it's called calcaneal cuboid. Talonavicular, in the same exact sense, your talus bone and your navicular bone. So this here is your talus. This here is your navicular. Oops. There we go. And the navicular we'll be talking about in a couple minutes here in terms of the tests we'll do for it. So again, bones you need to remember. Navicular, talus, calcaneus. Those are the three bones in the foot you should remember. You should also know your fibula and tibia. So those make up your ankle. So tibia is going to be medial. Fibula is going to be lateral. So 5 bones you need to remember from the foot and ankle: navicular, talus, calcaneus, tibia, fibula. The soft tissues you'll need to know, there's 3 groups of them. Well, 2 groups plus 1 extra. So the Achilles tendon is the major tendon you need to know. This is also known as your calcaneal tendon. And that's formed from gastroc and soleus. Your Achilles tendon, your calcaneal tendon is your thickest, biggest tendon you have in your body. So this is your strongest tendon you have. If you injure this, if that ruptures, you can't walk. The ligaments you'll need to remember are this group here, the talofibular ligaments and the deltoid ligaments. So you have anterior and posterior talofibular ligaments. Just like with the bones or the joints, your ligaments tell you the exact same thing. They just tell you which 2 bones are connected here. So talo means talus, so right here, and fibular or fibula right there. So your anterior talofibular ligament connects the fibula to the talus anteriorly. Your posterior talofibular ligament connects your fibula to the talus posteriorly. So if you were to remove everything here, you would see that the talus bone sits like this. So that's how you can have that connection anteriorly and posteriorly. So ATFL, PTFL, this is responsible for the lateral side of your ankle. Remember, anything that says fibula on it means lateral. And then your deltoid ligament, here we go, which is right here. This is what's connecting your tibia to your foot. So the deltoid doesn't follow the rule that tells the name of everything, but if you remember that fibular is lateral and deltoid then would have to be medial. So deltoid takes tibia and it connects it to a couple things. It connects it to the talus, to the calcaneus, and to the navicular. So deltoid is medial. So your deltoid ligament is your medial ankle. The most often injured place or soft tissue in sports as a whole is having an inversion ankle sprain. So what that means is that if we look at this, so we're looking at the ankle or the foot and ankle from posteriorly. So this is your posterior. So this is your heel. If you invert, it means that you roll onto the side of your ankle. So this would mean that your fibula would go touch the ground and you would see the arch of your foot popping up. So the posterior and anterior talofibular ligaments are the ones that are most injured. Your talofibular ligaments, these are the ones that get injured the most. Whoops, sorry, not the tibiofibular ligament. But sprained ankle equals talofibular tear. So the inversion ankle sprain is the most common injury you'll have in sports. It's also the most recurrent injury. So if you injure this, you have a very high percentage chance of re-injuring. Roughly about 25% of people that injure or have a sprained ankle from an inversion sprain will sprain it again at some point. If you go and sprain your deltoid ligaments from an eversion sprain, so deltoid would be an eversion sprain, that would mean that you'd roll your ankle inward. So your medial ankle would be touching the ground, your lateral ankle would go up. And if you do this, your life is in not a good place. I mean, yeah, it sucks if you roll your ankle on the side, like on this side, on the lateral side, and sprain your ankle. It's going to hurt. But if you do an eversion sprain, you're talking about damaging your entire leg. Because if you go into eversion, so if you drop your foot down this way, it'll actually put strain all up through your knee. Most likely, if you do an eversion sprain, you're breaking bones as well, which is not a good thing. I don't think in any scenario it's ever a good thing to break your bones. So again, deltoid ligament is your medial ankle. Your talofibular ligament is your lateral ankle. So you just need to remember those along with your Achilles tendon. All right, the arches of the foot we'll get into in a minute because we're going to do a couple tests for that. The muscles you need to know. So there's a bunch of muscles in the foot and the ankle. First thing to keep in mind, don't worry about any of these intrinsic muscles. Intrinsic muscles, they're very important. They allow, like, say, your bottom of your foot to move, top of your foot kind of thing. But they're just so numerous that if you're not a podiatrist, you don't really need to know these. So if any of you want to go into podiatric medicine, then yes, you will need to know these back and forward. But until said time, it's kind of above our pay grade here. So don't worry about the intrinsics. You remember the big ones here. So first off, gastrocs and soleus. These are your calf muscles. Gastrocs is superficial. Soleus is deep. So this is kind of a misleading picture because it makes the soleus looks like it's a really big muscle, and it's really not. It's pretty paper thin. So the soleus doesn't do a whole heck of a lot for you. Gastrocs is what does most everything for you in terms of calf. Because gastrocs originates on your femur, it also is going to assist you with knee flexion. So your gastrocs being behind your leg helps to pull your leg posteriorly. So because it crosses over the knee, it moves the knee. Soleus originates on your fibula. So it doesn't move the knee. The prime movements that these both do for us in terms of our foot and ankle is plantar flexion. What plantar flexion is when you take, so this is your leg, this is your heel, this is your foot, and here's your toes. And you put your toes on the ground and your heel goes up. I know that kind of looks like a tampon there, but you're standing up on your toes. So your heel is off the ground, your toes are on the ground. That is plantar flexion. That's the primary role of your calves, is to do plantar flexion. Now, as far as the other muscles you need to know, these ones are all going to tell you exactly where they're at and what movements they do. So keep in mind that form follows function. Whatever side of the leg the muscle is on, it has to move the leg in that direction, or the foot and ankle in that direction. So fibularis, fibula, lateral. You may see it also referred to as peroneus. So peroneus and fibularis are the exact same thing. That means equivalent. So if you ever see 3 lines instead of like an equal sign, but you get 3 of them, that means equivalent. So fibularis always the lateral side, so always lateral. If it's lateral, it means it moves your foot towards your pinky side. So the major thing that fibularis does is this right here, foot eversion. It's with plantar flexion. So it does help plantar flexion a little bit, but its primary role is foot eversion. Because this is on the lateral leg, it's going to move your foot to the lateral side. So it moves your foot towards your pinky. If you are just sitting straight, like with your feet on the ground, and you move your ankle outward, so you try to push your foot away from you, that is eversion. So fibularis or peroneus, eversion, away from your body. Tibialis, referring to the tibia, is medial. So this does two things. Tibialis anterior, tibialis posterior, they do two things. So tib anterior is your primary dorsiflexor. Both tib anterior and tib posterior do foot inversion as well. They do a little bit for plantar flexion, but that's kind of really a very secondary thing. What you want to remember for tib anterior is this does dorsiflexion. So this will take your foot and it pulls it up. So it pulls your toes up, heels on the ground. Toe up, heel down equals dorsiflexion. Because these are tibialis, so because these are medial, they will also pull you into inversion, which means that it's going towards your toe. So this would be if I were to take my foot when I'm sitting, feet are both on the floor, and move or roll my ankles or my foot inward, that's giving me inversion. Inversion means inward. So tibialis, medial, inversion. Fibularis, outward, lateral, eversion. I probably should have these switched, but that's okay. Now, just like with your wrist and hand, anything that says digitorum on it is going to move your toes. Specifically your second through fifth toe. Digitorum means no big toe. So it's your toe through your pinky toe or your fifth toe. So anything that says digitorum means all of your toes except the big toe. So no big toe for a digitorum. And all it does is exactly what it says, extensor, flexor. So this one, extensor digitorum longus, pulls your toes up. The flexor digitorum bends your toes down. That's it, real simple. Now, just like with the thumb, you had pollicus, which described all your thumb movements. With the big toe, you have hallucis. You may also hear it pronounced hallucis, but that means big toe only. Extensor hallucis is going to pull your big toe up towards you. So if your foot's on the ground, it pulls your big toe up towards the sky. Flexor hallucis bends your big toe down to the ground. So hallucis, big toe. So really, really easy there. Again, don't remember the intrinsics. And here's all of your normals. This actually shouldn't be 158. That's really wrong. 15. It'd be crazy if you could evert your foot 158 degrees. All right, so there's your rundown of the anatomy. We'll cover it again here as well. But now what I want to get into is your arches and test for these. Okay, you have 3 arches in your foot. You have 2 longitudinal arches and 1 transverse arch. Your longitudinal arches, you have a medial and a lateral one. They both originate at your heel. They insert on your 5th and 1st metatarsal. So your lateral longitudinal arch goes from your heel to your pinky toe. Your medial longitudinal arch goes from your heel to your big toe. This is kind of a misleading picture here because it makes it look like the arches are above your foot. They're not, they're below it. So don't let that confuse you. Your arches are below your foot, or below your foot bones, I should say. And then your transverse arch just goes along your midfoot. So the transverse arch is the actual arch you see. What these do primarily are kind of twofold. They do shock absorption, balance, and they allow you to help kind of grip the ground. So these all kind of allow you to squeeze your foot the same way you would close your hand. That's kind of what these would help you do. Now, the importance of these is seen in really static posture. So we have pronation and supination in the foot and ankle, but unlike the wrist and forearm, this is a static measurement. That means that you only see pronation and supination when you are just standing. So you have to be weight bearing. It means you have to be standing up. You're not going to really see this unless it's really bad if you're sitting. But if you're standing, that's when you'll see it. Where you want to be is in these middle ranges, like the neutral foot to having slight pronation or slight supination. That's where you want to be. If you have excessive pronation, that typically means you have a flat foot or fallen arches. If you have oversupination, it means you have high arches. Both of these are equally bad. You don't want either of them. As you can see, if I'm overpronated, I have this big angle outward here. If I'm oversupinated, I have this big angle inward here. Both of these put you in an unsafe range in as far as both ankle and Achilles tendon health. So your ankle and your Achilles tendon will be weakened and less stable if you have too much pronation or too much supination. So that's really where the importance of this comes. Now, the last thing we're going to do today is to actually quantify this, or show you how to actually do these. So two things we're going to look at here: navicular drop test and your arch height index. This here, this Physiopedia bit here, this is really going to be the best source for you to give you all of the foot and ankle assessments. So this gives you everything you need. It'll tell you everything you don't need, but everything you do need. So every single test you can have with that, that'll be on there. The two you're going to need to remember, or I guess you should know, is you need to know the navicular drop test and the arch height index. So those are the two things you'll need to know. here in measurement form. So I'll explain what all these mean here in a minute, but for your arch height index, if you have an arch height or an arch height ratio of 0.356 or greater, that means you have a high arch. If it's less than 0.275, you have a low arch. If it's in the middle, you have a neutral arch. With my navicular drop test, if I have greater than a millimeter change, it means I have a positive test, and that's for overpronation. And then if I had a less than 4 millimeter change, that's going to be positive test for oversupination. So the pronation is going to be much more common than the supination. And so now I'm going to show you how these actually work. All right, so hopefully you guys can all see my picture here. And what I'll actually do to make sure that that's not, let's see here. All right, well, hopefully you guys can see me here. right, so I'm hoping that maybe you guys can see me. I don't know why it's not showing all of the participants here. All right, so hopefully you guys can see my feet here. If not, then this is going to be terrible. But if I'm doing a navicular drop test, what I want to measure is how much my foot actually moves here. Okay, so now if you look at the, got it. Okay, so what you have to do is you have to make sure you go to the gallery view so you can actually see this. But here's my foot. When I do a navicular drop test, so again, this is my medial foot here. Let me see if I can turn this for you a little bit. There we go. All right. So the things you'll need to, or you should be able to point out. First off, you can just kind of tell just by looking at my foot that it is pretty darn flat. But this right here is my ankle. So that's my medial ankle bone right there. So that is your tibial malleolus. With a navicular drop test, you are measuring how far the navicular bone drops from sitting to standing. So your navicular, if you go from that ankle bone and I go down and over, you'll feel a bump right about here. So where you feel that bump, so again, here is my ankle bone right there. Down and over, you'll feel this bump. That right there is your navicular bone. And what you would do for this is you want to mark it. Maybe. Sorry, I'm just trying to do this with a holding a whatever, an iPad. So that's why everything keeps getting a little screwy there. All right. So here you can see right where I've marked my navicular bone, that nice little dot there. What you'll then do is you'll take a piece of paper and you would put it right up against that. And what I'm going to do is I'm going to mark on that paper where this dot is. So about right there. So there you could see that on the paper is where that dot is. And then what I'm going to do is I'm going to stand up. And now you'll see how that dot has changed quite a bit. And now I'm going to mark where it is now, which is right there. And that is my navicular drop. So again, if I'm sitting down, you see that my navicular bone lines up with the paper right here. Okay, so that's why I make that first dot, is where that navicular bone lines up there. When I stand up, that navicular bone drops down, and then I make a second dot where the navicular stopped. Now, what I do with that So now that I have this here, all I'm going to do is take a ruler and I'm going to measure the distance from one to the other. And I measure it in millimeters. So this side here is your centimeters or your metric side. The other side I have here is inches. Make sure you're going on millimeters. And you can kind of tell, so that's 0. I'm at roughly 14 to 15 millimeters. So about a centimeter and a half of a drop, which is big. So that is going to be considered a positive test. So this here is about, let's say, it's about 14 millimeters. So that is how I quantify my navicular drop. Now, for the arch height, so if you go back to the screen here, your arch height is this. And for whatever reason, my pad is not letting me use the microphone on it, so I really can't do this too much for you right here. But what you would do is you would first, and you can do this really just sitting at first, but then you want to do it standing to get the actual measurement. What you'll do is you're going to measure your overall foot length, so from the back of your foot to the edge of your big toe. The halfway point you have is where you're going to measure your foot height. So if my foot were, let's say, 12 inches long, so if that were my actual foot length, this would be at the 6-inch mark. And then I measure how tall this is, or how high that is. That's your dorsum height, is just how high your foot is at the halfway mark. So you would measure this, and if I measure mine So I know you can't see me, but if I measure my foot, it is approximately right at 12 inches. So I'm about at 12 inches. So this actually would be accurate for me. So at the 6-inch mark here, so this would be 6 inches to the middle, 6 inches to the end. That's where I'm going to measure the height of my foot. Now at that 6-inch mark, I'm measuring the height of my foot, and it is roughly 3.5 inches for me. So my dorsum height is 3.5 inches, and that's just for me. Now your truncated foot length is the length of your foot from the back of your foot all the way up to the ball of your foot. So what that looks like and again, hopefully you can all see this. Sorry, I'm just having trouble getting my foot to actually get in the picture here. What's weird is it's off center, so it's not even online with this. Okay, so from here to here on me is 12 inches. This approximately is my 6-inch mark, or my halfway mark. Okay, so that's approximately my halfway mark. From the top of my foot to the bottom of the floor, so from here to here, that is about 3.5 inches right there. That is my dorsum height. So that's what I'm using for the dorsum height. My truncated foot length goes from the very back of my heel all the way up to the ball of my foot. So where I see that big toe joint there, so right here, that is my truncated foot length. So from there to there. It should obviously be lower than your full foot length. So if I measure this, actually the easier way to do it would be to go from here to the end. So that's about 3 inches. So this truncated foot length for me is about 9 inches. So for that, we got 3.5 inches. For the truncated foot length, we got 9 inches. And all I do is divide the two. So if I take 3.5 divided by 9, so that gives me 0.38, which doesn't seem to be correct. Probably because my measurements were probably off there. But this is actually saying I have a high arch, which clearly I don't. So this just kind of means that perhaps my measurements were off. Let me double check this. Yeah, I could read. So yeah, like I was saying, my measurements were off there. My dorsum height is 2.5 inches. My truncated foot length is 9 inches. That's going to be a big difference there. So 2.5 divided by 9, there you go, 0.27. So for me, technically, that 0.277 would be in the normal range, but I'm kind of saying that's within the margin of error because I know I have flat feet, so I do have a low arch. So hopefully if you're measuring yourself, that you would be able to do a little bit better with that. But at least now, hopefully you have a decent idea of how this actually works. So those two ways to quantify pronation and supination, the arch height index, which you would use based off this, and then also your navicular drop test. The navicular drop test is a lot easier to do because it's just really one measurement instead of multiple ones. But I've already talked for way too long here. I know this is well over an hour, but hopefully this gives you at least a better idea of the anatomy and some of the measurements you could take with the foot and ankle there. We'll go over this again here next week, but I will let you guys go from here, and then I will see you all on, well, next Monday.